I want to build a Star Wars themed controller for a big project I've been working on. It will bring something I've been building for years to life. I'll reveal exactly what that is at the end. I've always enjoyed the aesthetic and design language of the hardware in Star Wars and the tactile nature of their interfaces. I wanted to make sure whatever I built felt like it belonged in a universe. First component would be the Arduino. This would be the brains of the operation. Next would be the NRF radio module, which is used to communicate with whatever device I need to control. A small OLED screen for changing modes and status output. A rotary encoder for changing menus and changing modes. 2 potentiometers. A latching switch button with red LED. 2 momentary switch buttons. An 18650 battery cell with housing, a charging board for the 18650, a piezo buzzer for making sounds in the menus, a buck converter to bring the voltage down from 5 volts to 3.3 volts for the radio module, and a boost converter to bring the voltage from 3.8 volts up to 5 volts for the Arduino. And lastly, some LEDs for aesthetics and potentially indicating what mode we're in. Next up is some old hardware in the form of X and Y analog input sticks. I could buy new hardware for this, but it's much more cost effective to buy old flight radio controllers secondhand. Hardly anyone uses analog radios anymore, so they're available cheaply and the input sticks are usually of great quality. For modeling the controller I used Fusion 360 and I came up with a design that I was pretty happy with. I felt like it had captured some of the Star Wars aesthetic with the inlay outlines and the black paneling on a grey background. The LED buttons would also add to the aesthetic. I went for a classic layout for the 2 stick locations, and the center module would be where the 2 potentiometers and the OLED screen and rotary encoder would be. I ultimately ended up going with a different design for the lower knob for the rotary encoder. Behind the face inside is some room for mounting the Arduino and the various electronic components. At the back we have some Arabesh, just some flavor text basically, just to add in to the aesthetics. And underneath you can see where a mock-up of the scale of the Arduino Mega is. I had initially planned to use the Arduino Uno, but I ultimately ran out of inputs, so I ended up upgrading to the Arduino Mega. There is ways to make more inputs for the Arduino Uno, but ultimately it was just a lot easier to use the Mega and I had one available. I lost some of the original print footage, but basically it was just a lot of printing, and then once it was all out I did a rough assembly. You can see I glued in the inlays and added in some of the buttons. And I had a new button or a knob for the top of the rotary encoder. You can see that there's some existing wires from the flight sticks, but I needed to swap them out for JST connectors, so I had to crimp new ends on those. It was finally time to start in the electronics. Here you can see me starting up my soldering iron and grabbing some solder. I tend to use leaded solder about 350 degrees, and because I'm using leaded solder, that's why you see I'm using latex gloves here, just because I don't want to have that lead stare. Here you can see me working on the center module with the 2 potentiometers. I ultimately went with a slightly lower profile potentiometer here, and yeah, just the 2 potentiometers on the OLED screen here. They both share a common 5 volts and ground, and then there's some headers at the back that you can see. So it's 5 volt ground, the 2 I2C pins, and 2 analog out pins. Here I'm just checking for continuity. I did a quick test with the Arduino, just outputting something onto the screen and reading the values of the potentiometers to make sure there wasn't any issues before moving on. You can see here I've made a large shield for the Arduino Mega, and that fits nicely inside the case, and you can see all of the JST connectors that I have on the top of them, so ready to accept them. One issue I had though was that the original cables that came from the flight sticks weren't JST connectors. I actually thought they were initially, but they're a slightly smaller size, so I ended up cutting all of these off and swapping them out for real JST connectors. I did consider taking the original smaller header sockets off the original controller, but it was really difficult to desolder them for some reason, so in the end this just worked out easier. Here you can see me pre-tinning the wires. And I'm really glad that I actually remembered to put on heat shrink tubing here. Once all the heat shrink tubing was on, it was time to solder up each connection. You can see I'm kind of floating here because the wires are kind of short, so a little bit shaky, but I did get the job done. And a quick test to make sure that the connection is solid. And that was the first connection, and there was another 3 to go from the flight 6. I'm just using the edge of the soldering iron's heat to shrink the tubing on the outside there. Next up was testing some of the LEDs. You can see my power supply is set to 2.7 volts, just to do a quick test without any resistors. And that's 2 white LEDs and 1 red LED, and yeah, that's a reasonable voltage that will light all of these. For the actual insides, I have resistors built onto the main board for the LEDs inside the buttons, so you can see lighting up here, and the LEDs on the lower section for the status. Next was testing the charging board for the 18650 cell. I'd never really used this type of charging board before, so I was a little bit scared of it. That's why I went outside. And I had already actually lit one of these cells on fire by using a cheap housing before. Once I slid it into the housing, it had a sharp point that punctured the end of the cell, and I had to quickly go outside. So I learned that lesson once and didn't fancy having another fire inside. One other issue was that I had had these in storage for quite a while, and you could see that there was 2 lights on, a blue one and a red one. You should only ever see either a blue or a red on those boards. If you see both, there's a problem. Thankfully, I spotted that pretty quickly and then swapped it out for another board, and it worked flawlessly. Next, you can see me crimping some of the ends of the lines to go into the JST connectors. This took a considerable amount of time. I always need to check the YouTube videos, probably about 6 of them, before I can remember how to crimp things nicely. Checking continuity once again once the JST connectors are plugged in to make sure I didn't introduce any new shorts. Next, I'm inserting some of the tabs inside the housing. This is just a shelf that the insert fits onto so that it doesn't slide through. And then there's enough filling with the Arduino and wires at the back that it presses in quite nicely against the back of the housing. I'm just gluing in the housing from the 18650 cell down into the shelf now. And you can see in the background there is the charging board and the boost converter and a buck converter, one for bringing up and one for bringing down. Underneath the red and black wires go to the red LED button, and that serves as the on and off switch for the controller. Back to the faceplate, I started gluing in the center module right onto the face, so that just needs to quick connect with some header pins and it's ready to go. The shield was ready to insert in the Arduino Mega, and once I pushed it in, I checked again for continuity to make sure there wasn't any new shorts. checking each pin for all of the headers, just against the positive rail and then the negative rail, and again for the positive and negative rail for the 3.3 volts. Here you can see everything working when powered from a power supply. I was pretty happy at this point, it had been a long time. You can also see an electrolytic capacitor there. That's just for smoothing the power output to the radio module, so that's going across the positive and negative 3.3 volts. And it was time to close up the housing. Once the faceplate was secured, it was time to add the knob onto the front for the encoder, and then it came time to write some software. After many hours of writing software, I wrote some custom UI for the OLED screen and the input, and then the project was ready for its final reveal. Powering on the controller with the red LED button, you can see that the status LEDs start flickering on the bottom left and the screen comes to life. Here you can see me navigating to the status page, and as I wiggle some of the inputs you can see that the values are changing here. We can see the X and Y values for the left stick changing on top and the right one before, and the same for the knobs. You can see K1 and K2. It's kind of difficult on the screen. The refresh rate is matching up with the camera, so it's a little bit shaky, but in real life it's very smooth. And you can see me navigating back with a long press and then a single press to get into some of the servo control. So this is going to be helpful for when I'm debugging my big project, which is being able to select a bunch of different motors. And you can see here I'm able to navigate into a menu, and you can see my other buttons are ready to light up. So blue is to confirm a new value, and I can press the blue button and it will send that value off on the radio. And I can also choose another value and it'll either send directly when I choose the white button, or it's basically going to be continuously sent when the white button is pressed, or just a one-time send when the blue button is the one that's activated. But yeah, I have a lot of flexibility here. The menu system is very easy to go through, where you basically just long press to go back a step and a quick press to go down a step when you select things. And I can basically program it to do whatever I want, and any of the radio outputs can be changed here also. So you're probably wondering what the big project is, and some of you who've looked closely at the menus might already know. But I'm building a full-size Astromech or 5G4. This is fully my design. I've been working on it for the last 3 years. We'll be fully autonomous, capable of converting from 3-leg to 2-mode and back. If you're interested in following along, please subscribe for future updates. This is also my first properly edited YouTube video, so if you have any feedback, let me know in the comments. And if you like the video, please feel free to use the thumbs below. Thanks.